Alright guys, my last video didn't go too well. Hope the light's good. It's been a while since I've edited videos and I've had nothing but problems with my video editors. I tried different ones and it just didn't work. There was something wrong with the way I used Power Director. And it was Power Director 16, but it was something wrong with the way the thing worked. It glitched, it had problems processing, it just crashed. I don't know what its problem was. So I got rid of it, went to Corel, didn't like how it worked. To me it's a harder way to use, a harder program to use. So then I tried a free program called can't think of the name of it now, but so after a few days of messing around with it, I went and reinstalled my Power Director 16, updated it, and it seems to work fine. It's done everything I wanted to do. So anyway, that's that. I know these videos kind of crappy, getting dull. I don't edit them good, but I did have some problems, and hopefully I can get a little better at this the more I do. Anyway, what I have, something kind of old and interesting, and it's just been on my bench forever. And it really, I don't have a use for it, but what it is a Sencore. It's an old TV analyzer, and I have no idea. Yeah, here it is. TV, VTR, EMA TV, and video analyzer, made by Sencore, and somewhere along the lines it has a model number, a VA48. Horrible light. Anyway, it has a couple of things that I use from time to time, and it doesn't turn on. If I plug it in, I'm going to plug it in my Variac. I'm going to plug it in. I'll show you my Variac here. Let's see if I can get to it. I'm going to zoom you in here. Alright, I'm going to turn it on. Output is right at 118. I'm going to change the setting to 175 watts, and I'm going to turn the front power switch on. This thing is not drawing any current at all. So, what are the odds of that being just an internal fuse and maybe some kind of issue? Don't know. Let's unplug it and find out what's up. Could be as simple as a blown fuse. Fuse is right there. Hope it ain't a fuse, but then again, if it is a fuse, then fuses just don't normally blow by themselves. Get it out of there. Well, the fuse is not shorted. It is a catastrophic failure. Sure. There's a spare fuse here. So what we'll do is we'll put the fuse in here. Place it. And I'm going to set up my dim bulb tester, so we'll be right back. Okay. The dim bulb tester is set up. It's hooked to the output of my Sencore AC Ta-48 variable isolated transformer safety analyzer. So turn the voltage all the way down on it, and don't listen to that guy. See if I can get all that in one shot. We'll try zooming in a little bit. I wish this camera had a remote control. See what happens. I'm going to turn the device on. Matter of fact, hold on. Let me do this another way. Alright, let me do this way. I think that'd work a lot better. Let's see what happens. Power all the way down. I'm monitoring the current / wattage. Power activated. Device is turned on. So let's increase the voltage. I had a little rate increase in voltage all of a sudden. Current. Oh, and it just jumped up all of a sudden. Something kind of wonky going on in there. My current draw is going all over the place. My output voltage, I'm right about 70 volts. I am drawing approximately 80 watts. What's going on with this thing? I don't know what. I turned it off, turned it back on. Still drawing current. That's weird. Did you see the watt meter on the power supply? It just jumped up. That's odd. Like a tube or something. It ain't got tubes. So, what's up with that? Oh, let me take it apart, see what happens. Alright. Got this bad boy taken apart. Don't really smell nothing. Don't really see nothing out of place. There's a diode missing on this board. CR13. Looks like the power supply board. I don't know where that diode would went because I didn't get it. Not really seeing anything out of the ordinary. Here's the line cord going in. Here's the fuse receptacle right there. However, there is a black wire going to the pilot light that's trapped underneath the cover. Don't know what happened there. I don't think that's a problem, but it doesn't need to be there, so we'll liberate it, get it out of there. Smash flat. Who knows? It could be it. Doubt it, but who knows? I'm not even sure I even want to work on this thing, to be quite honest with you. I don't use it. The only time I've ever really used it is for a different power supply. It has a 35 volt power supply, 1 amp on this thing for use for what different things. So anyway, I am going to power this thing back up. see what happens. Make a couple voltage measurements on there just to kind of get an idea of what's going on. I do not have a schematic on this thing. I've never been able to find a manual because I didn't want to, I was too cheap to pay for it. Especially with something I'm not going to use again. I'm probably just going to wind up taking this thing apart for parts, use hardware and stuff. Just got a few things on here that's worth having. Alright. Power supply back on. We're going to run it up to about, we'll run it up about 80 volts. Our switch is on. That scared the daylights out of me. No current again. Bulb is not on. Did we blow a bulb, or did I just not hook this thing up right? Nothing as of yet. Is it the fuse maybe? The fuse give up the ghost? Not drawing any current. I have an output of about 70, about 80 volts. Fuse like it's still shorted. Try again. Yeah, it might work better. Turn it on. Still drawing various amounts of current. Ain't sure about all that. So we can do this 100 different ways. I think I'm going to use my trusty old triplet meter here. Model 630-PL. Just make a few little checks here and there. What have I got to lose? See, no voltage on there. This appears to be a pass transistor of some sort. Nothing there. Appears to be a negative voltage on that count. Not too dang much though. Let's see, 50 volt scale, that would appear to be roughly around 20 volts going back and forth. That's a negative voltage right there. About a -10, whatever that is. So, what's up with this thing? Is there a short? Is there an open? Let's see, where is the main power supply? Identify the power transformer, which is this guy right here. This is your primary here. It's got got a black and red with a white and red. So that's going to be your primary. And then the secondary right here. All the secondary leads comes right here to this board, which I doubt you can see in that angle. The board right there. Got all the filter caps on it. The Sencore Ta-48 as in boy, 130-A as in Adam. So the whole pile of capacitors and diodes and all that mess on there, but I'm not getting any voltage to this transistor. So, what's up with that? I don't know what half of this mess is. disconnect some of this mess. Better be careful here. I don't know what this stuff does. Like I said, I don't have the manual on it. It doesn't really interest me if it fixes this thing or not. Okay, I disconnected a bunch of those leads. That's most of the load off this board. Still drawing quite a bit of current for nothing to be hooked to this thing. As far as I can tell, all the outputs of this power supply board, I've disconnected all the outputs. I'm still drawing quite a bit of current. I don't know if this is worth messing with, to be honest with you. I thought it'd be an interesting little take of a video just to kind of get... There is no voltage on this transistor at all. Really odd. Nothing on the base, nothing on the emitter, nothing on the collector. I do smell something getting warm. I don't know what that would be. It smells like one of these big old 10 watt resistors. Get about 20 watt, 25, 26.5 volts on one side. It's the same on that side. I got a 100 ohm 10 watt resistor here. A lot of negative voltage on it. Yeah, about 22, so those are I have no voltage on this transistor. That was like a pass transistor. Still drawing about 85 watts. Pretty good amount of watts. That's about 25 volts on that side. Let's see if I can do this without grabbing that transistor right there. Short it out. Oh yeah. Got a big voltage drop here. Now whether that's normal or not, I have no idea, but I've had to increase up to 250 volt scale. I got probably about 90 volts on that side. Yeah, 75, let me see, 75, 80, about 85 volts on one side. And considerably lower on the other side. So that's the only thing that seems to be drawing current. The 20K 10 watt resistor is labeled R2 on this here board. I really don't want to touch that with my finger. Pretty sure that's going to be hot. I'm going to touch these other two. Technically, it's not really that warm. But a 20K though, dropping that kind of resistance though, probably wouldn't, I mean that kind of voltage wouldn't get that hot. I don't know. Let me take that power supply board out. Alrighty. Get rid of that noise back there. Alright, this is the power supply board, if you want to call it that. Turn it up here where I can see it. Power supply board right there. I don't know what gives it away as a power supply board. Let me see here. Boy, I need a... Anyway, there was that diode I was telling you about, CR13. It's a really discolored spot there. I don't know. You can get something to point with. What have I got to point with around here anymore? Oh my Lord, let's see here, right here. Find it, where you at? Where you at? Oh. That diode right there that you can see light shining through. I actually found it. It was actually on the other side of the board here, and a lot of heat damage here. Anyway, it was here to here. It was soldered on the bottom side. Now, I don't know if I've done this some years ago or not. I don't remember. But it promptly just fell out. It's right here. This is all backwards. Anyway, it's not much to see, guys. I have to get my glasses to see what it actually is. If I can even see it. It's got a Motorola marking on it. Can't really tell. Bring out the magnifier. It has no markings on it. So, let's see if it's even good. Put it on the R times 1000 scale. Yeah, heck, we'll just put it on R times 1. Do what they call a front to back. Yeah, let's see if that diode's going to check good. Let me bolt this down. Sorry about the jerkiness there. Yeah, we'll get y'all. I'm sorry about that. Alright, here we go. Just try not to tear up my glasses. Okay, I'm going to measure the junction of this diode just to see if it's any good. I'll put it on the R times 1 scale, and I'm going to put 1, no junction that way. Well, whatever this old diode was, this ain't diode anymore. Whoop, wait, take it back. Got a junction. We do have a junction. As you can see, let me zoom out. Measure it one way. I know that's hard to see. Doesn't get any reading on the ohmmeter. I want to measure it the other way, and I get about 500 ohms. So it is a good junction. So it's a junction on the Zener diode, which has got to be what this is. Junction's good. It means the diode is not bad. I just don't know what the diode is because I can't see the marks. I would like to replace this diode. So how do I replace this diode if I don't know what the marks is and I don't have a manual? Well, I'm tempted to just make this thing into garbage and throw it away. I need the room on my bench anyway. Or we can measure this diode to see what it actually is doing, and all I would simply do there is use a variable power supply with a resistive load and a voltmeter. I'm not really worried about the current. I just want to know where it clamps at. So with that in mind, we'll take my trusty little Heathkit tri-power supply IP2718, and I'm going to turn it down. I'm going to get me probably 1000 ohm resistor. Be right back. 1000 ohm. Fine one. Yep. Have to get on to my stock person. Anyway, the diode is it's a Zener diode, which are normally connected in the circuit reverse biased. So the negative lead of the power supply will go to the negative side. We will use this voltmeter here to measure the voltage across the diode. Negative power supply lead goes to the excuse me, goes to the anode of the diode. Man flu. Anyway, negative side of the power supply goes to the anode of the diode, and the negative side of the voltmeter goes to the anode as well. Now, positive side of the power supply, the variable power supply, which is turned down, will go through a smaller value resistor. I wanted 1000 ohm, didn't have one, so I've got a 3900 ohm resistor instead. All I'm wanting it to do is sink a little, is drop the voltage across this diode. So my voltmeter is now in series with the diode. I'm sorry, my voltmeter is across the cathode of the diode. Remember, a Zener diode is reverse biased. So if you're in a negative ground circuit and your Zener diode is in the circuit to help reduce the voltage, your anode will be to ground and your cathode would be to the positive side on the load side, if you will, of your dropping resistor. So with that being said, apologize for that. So what I want to do now is get you guys moved over here. Let me see here. Make this work. All of a sudden I'm going to have fits of coughing. I may have to use my... Alright, well, this thing is not capable of that shot. Boy, it's such a lousy video talk. Oh, there we go. There we are. Oh, had it. Lost it. So what I'm going to do, so I'm going to increase the power supply voltage and watch the voltage on my DC voltmeter. And all I'm wanting to do is see it where it stops at. Now it'll tell me the voltage of this Zener diode. So I'm increasing the voltage. I'm up to a volt on the output so far. I'm up to 4 volts, 5 volts, 6 volts. Still increasing, as you can see. I'm still increasing the power supply voltage. I'm up to about 9 volts. Coming up to 9, I'm passing 10. We're 11.6 on the voltmeter. 12 volts, 12.8, 13. We're up to 14 volts. And it's still climbing. What is this thing? This thing might not be a Zinner at all. Oop, I am overloaded. You know what? I'm at full voltage. Thing may not be a Zinner diodes, ladies and gentlemen. Well, ain't that just a snick in the pants? Yeah, we'll put it here. We can go up a little bit higher with this one here. Of course, you can't see it. I can. I think this thing may not be a Zinner diode. I'm just going to keep raising it until it clamps. Well, you know. Bad when you ain't got a schematic on this thing. What do y'all think I ought to do with it? Trash it? Because I don't use it anymore. Kind of a waste of time. Kind of a wasted video. I'm looking at some of these other diodes on the board to see if I see any other thing that might be. There's a diode over here, but it's marked CR14. Doesn't indicate whether it's a Zinner or not. I just assumed it was a Zinner because of where it was in this circuit. It's all CRs. See, CR1, CR2, 3, 4, 5, 6, 7, 8, 9, 10. This one's case CR13. There's a CR14 in here. So, I don't know. We'll see if I can find another diode and put in it. Alright. Watch your back. Assuming that was because I didn't see it clamp at any voltage, I assumed that diode was a standard old, just a regular standard rectifier. Okay, and it wasn't a Zinner diode. If it was, it clamped at a lot higher voltage, and what I mean clamp is a Zinner diode is it breaks down at a predetermined voltage. So if a 12 volt Zinner diode, if you measured it, it would check just like a regular diode. You did a front to back of the diode, which is what like I done a while ago on the meter with the ohm meter. It would still measure like a regular diode. However, a standard diode, if you put a reverse voltage on it, like, you know, the reverse bias, it would not conduct at all the way up to its breakdown voltage, which is usually 600 volts or something like that, depending on the diode. But a Zinner diode's got a built-in breakdown voltage. So at a 12 volt, so like a 12 volt Zinner, as that positive voltage on the cathode approaches 12 volts, it starts to conduct, and its resistance goes down, which is why you need a ballast resistor in there or a drop-in resistor, which is what that 3900 ohm resistor was, to drop the voltage, because it can't sink that current by itself. It's got to have a resistor in there to help it. In this case, I brought the voltage all the way up to 30 volts, and it didn't clamp. And I can't see this thing having a Zinner diode bigger than that. It's possible. Hell, I don't know. Anyway, I went ahead and replaced the diode with a 1N4007, which is a standard 600 volt PRV 1 amp diode. And I soldered it in such a way, gave it a little bit more leads on the bottom. I went ahead and put it through the top of the board, gave it some more leads on the bottom, kind of moved it over, and hopefully it'll help dissipate some of the heat. So I guess what I'll do now is kick the camera. I think what I'm going to do now is just do a spot check of some of these rectifiers just to see if maybe we might have one that might be a little off. So again, I'm going to use my ohm meter and I'm going to spot check some of these diodes. I got a front to back on that. All I'm looking for is when you measure a diode with an ohm meter, measure it one way, it's going to be no resistance or infinite resistance. And you flip your meter lead polarity around, it will measure all of a sudden somewhere in the range of 500–600 ohms, depending on what kind of meter, what kind of a diode you have. Now digital meters, like your DMMs, can't talk today, they have a diode function which looks like the symbol of a diode. That puts a bias voltage out on the leads there, and it measures what that drop is. If you put it across if you forward conduct the diode, it will measure the voltage drop. It tell you whether or not the diode is good. Usually, if a diode has a forward and reverse voltage difference, or if you're able to turn the thing on, then the diode is usually good. Now, also on these little diodes here, you'll notice there's a band on them, a white band usually. That band is the cathode side. That's normally the side that's output. That's what gives you your positive output. If you turn that around while you're going to have an AC source supply to it, it will give you a negative voltage. But most of the time, the cathode has a band on it. These old diodes. Hard to check them. Those all check good. Front to backs on them. I don't see any heat damage other than that diode that we checked a few minutes ago. If you see a diode that's shorted or open, in other words, you don't get what they call a front to back, then it's bad. Simple as that. Or if you get a voltage reading both ways, then the thing is bad too. But it should have resistance one way and no resistance on the other, and the resistance is usually in the order of 500 ohms. I'm not really seeing anything out of the ordinary here. Mr. Grins and Wiggles, I'm going to check this here transistor and this TO3 case. Seems to be good. I don't know. I'm going to throw the board back in there and I'm going to try it again. Alright. After looking for that missing screw for the back, 300 hours, got the board back in the device. Just plug everything back in on the off chance it might have actually fixed it. Diode being loose. I highly doubt it. Couldn't be that easy. Alright. Run this back around here. I'll get back up to our setup. Yeah, I'm gonna have to build me something from my dim bulb assembly. Let me move this around because that thing does not do nothing but get in my way. I keep tripping over it like the old clumsy old man that I am. Alright, well, alright. Everything's ready to measure again. I got everything set up like I had, so let's fire it up. Of course, that voltage is all over the place. It doesn't really make any sense to me. Still no voltage on that transistor, whatever that is. There's no voltage coming out of these diodes. What's up with that? I'm drawing about 80 watts. I mean, that transistor has absolutely nothing on it. And I think, if I remember right, that transistor is the one that gives me the 30 volts. There is nothing on that. Transformer is getting a little bit warm. It's current limited over here with the dim bulb, which is glowing. It's got a little glow to it. There's absolutely no voltage on that diode. That's on that bridge rectifier, the heavy looking bridge rectifier, which I'm thinking is the rectifier for this, which I think is the 35 volt rectifier. So, with that in mind, I'm going to go back and I'm going to measure for nothing there. Don't know. I'll get you back. Alright. Took the power supply board out again. And the 35 volt output, which is on the front, which is what they call bias and B plus substitution. There's a DC output voltage of 0 to 35 volts at 1 amp. Connects to this plug right here. those plugs, let's find the output. Let me find the output. Need a flashlight for that. You notice I've had a schematic. With the black wire and the red wire, that is the output. The black wire and the red wire are on opposite ends of this plug. So the black wire and red wire, which is the output, goes into this plug right here, which I can't tell you what the number is. Doesn't have any numbers, so one of these is black, one of these is red. Don't know if that's a floating top supply or what. So let me get my meter out. I think it's a floating power supply, which means this won't be tied to ground. But I do know there it is. There's your minus. Okay, there's your minus, here's your positive. So this is minus on this board right here. This pin right here. And here's your positive. So let's figure out where that bad boy goes. Oh boy, it goes through a diode. How about that? Goes through like a 100K resistor, which is inconsequential to me because that goes to ground. Goes through that diode. So what do we do here? Don't know. I got two other leads on here, which goes. There's an orange, a yellow, and a black, and a red. There's 4 wires. Two of the leads there, the orange and the yellow. That goes to the variable control. So the output is plus. That comes from the emitter of this transistor, but for that transistor to have any output voltage, it's got to have collector on base voltage. I'm sorry, collector. You have to bear with me, guys. I'm suffering from a head cold. Can't think straight. The collector is the one that has the unregulated voltage on it. That comes from this capacitor here marked C4. That comes from the rectifier bank. So I should have had earlier voltage on that. But however, it may be isolated and I may have been looking for the negative in the wrong place. Let's see if these two negatives are in the same spot. They are. Well, alright. Well, with that in mind, I guess I need to be able to measure this again. I'm going to plug it back in. This time, I'm trying to do it with the board out of the device, so I ain't got to keep unscrewing and screwing and unscrewing. I'm just going to kind of lay it down like that. Hook up my test set again. Let's see what we get this time. Well, the capacitor is a 75 volt capacitor. So let's see what happens. Go with the biggest ball of fire you've seen. Drawing a little bit of current. This time I'm going to measure directly on the minus. Positive. No voltage. I have a voltage on the collector. Imagine that. To give 30 volts out, I got to have 30 volts in, and I'm running about 24 volts. So the emitter, I do now have voltage coming out. Who'd have thunk, right? So I got that taken care of. Well, let's just run this thing up. Let's just run it up to full power. I am drawing with the light bulb in series at about 140 watts. Wow. That's just with this stuff hooked up. That's a lot of watts just for nothing basically tied to the power supply. Other than the inputs in that one transistor stage. It's running cool as a cucumber. That's a lot of watts. Be nothing there. I'm going to unplug that board just to see what the transformer does by itself. Practically no current flow with that all disconnected, of course, like, you know, who'd have thunk that too, right? So, where's all the current going? So these old diodes are getting pretty hot. Hold that thought. Okay. Had to go out to my work truck to get a special tool. I want to find out what exactly is getting hot. Give me a clue as why I'm drawing 175 watts power on something that shouldn't. Oh. Hit the right button, it might turn on. Let's just bring out my dusty old flare, TG167. Let's have a look. Let's see, let me get you over here where you can see. Turn that display around where I can see. And oh my gosh, let's see, alright. I'll eventually find what I'm looking for. I can't see it because, there we go. I'm getting hot. Looks like that third diode. Let me turn this off. This flare is kind of sensitive. What I want to do is just let it kind of die down. Put you down. Okay. What I thought it was not it. I can get you in here and all this stuff. I'm going to use my pointer. Well, this ain't working. It's working like a toothache in a candy factory. Well, okay, anyway, that ain't working. This is the hot spot, CR1 right here. That dude there is the one that's drawing the most current. So, I'm going to put you back down and I'm going to take this back off and we're going to see where this stupid thing goes. Alright. So make sure the power's turned off. Pull that loose, pull that loose. Alright, we'll take the old flare, done this job. Wish I could have figured out a way to make that look a little better. They say practice makes perfect. Far from perfect. Well, I got lots of practice to do. So, move that back out of the way. Let's see. Turn it up there. Yeah, let's bring that up a little bit. Let me loosen that up a little bit. Let's see if I can get this. Yeah. Need a little more room. Need a bench cam. I need a monitor that I can put in front of me tied to the. Anyway, it's CR1, which is right here. That's the one that's getting incredibly hot. CR1's the anode goes to pin 5 of whatever this plug is, of this plug here. Because that's pin 5. Goes to CR1, the other side of CR1 goes over to a capacitor of all things. And from that capacitor it goes in through a 33 ohm resistor, which goes to another capacitor. Goes to this big old resistor right here. I wonder if that's what's drawing 175 watts. So all I'm going to do is I'm just going to pull that resistor off. Pull that resistor off. And recheck the current draw and see what else happens. But I guess while I'm waiting on the soldering iron to warm up, I'm going to remeasure. I'm going to remeasure the resistance. Make sure we ain't got no shorts. Not seeing any shorts. Nothing I would call a short. That's capacitor building up. know, it could just be normal. I don't know what would have blowed the fuse. Alright, soldering iron has finally decided to heat up. I'm just going to pull that diode, one side of it. Diode pulled. Go ahead and clean it out. Alright, diode pulled. Alright, place the power supply back into the device, theoretically. See what happens. Power up. Well, there goes my current draw. It is not drawing any current now. So that was drawing 175 watts. That's amazing. I'd be very interested to know what exactly does that do? And where does it go? How does it do it? Why does it do it? I haven't been able to find any information on this thing online, which is kind of odd. I thought Google could find anything. Yeah, I did. Sorry about that. I keep running in the camera. You alright? Didn't mean to bump y'all around. Let me put that tree and that diode back in where it came from. Thing might just do this, I don't know. Just don't think it should be pulling 175 watts with it not connected to nothing. And again, these are really kind of wasteful power circuits. That's the filter section. It's a pi filter section using a 33 ohm resistor as the null developer, because it comes from that diode into that capacitor right here, which I can't tell you what value it is because I can't see the writing, because the writing on the opposite side goes through the 33 ohm resistor to this side of the capacitor. Alright, so and then from there, let's see, goes into some other diodes, which is high values. That's all. Let's see. Yeah, look at there. There's that big old resistor again. And there's a diode. Couldn't tell you what that diode's for, but it does go into this resistor. That resistor had voltage drop across it. That's that big 20,000 ohm resistor right here. Goes into this right here, whatever this double plug is right here. Power supply for something. Goes into these two wires here. Comes over here to this wafer switch on the front, which that wafer switch is the drive signals. The thing is not connected. Why am I drawing that much current? Something that's not even connected. Kind of strange, I guess. Definitely is drawing current through it. I saw it get warm on the flare. I don't know, y'all's guess as good as mine. I'm just fiddle farting around in this thing trying to find something to work on so I can check my video editing software so I can make this stuff look a little better. It had a fast charge to it. That doesn't indicate to me that anything's wrong, but I'm going to go on this side. A little bit more resistance there, but nothing to sneeze about. I don't know what that is. I mean, I'm assuming it's rectified. I mean, it's based here. I don't see a problem. Could be normal. Check these here transistors right here. There's two sets of transistors here, and the more G based, the more gray ones. I mean the more red ones. Checking the forward to back junctions of them, and I got a forward to back junction there, which indicates to me it's good. We'll do the same thing right here. Well, this one's showing a little shoddy here. I'm showing about 60 ohms that way, and this one's definitely different. There is a difference in this one right here. This transistor right here, if you can see it, my battery ain't dead. Here's transistor, that dude right there. Not checking too good. Couldn't tell you what it is. Doesn't appear to have value on it. It's a G marking on it. But, hell, let's pull it off. Pull it off and I'll check it with my transistor checker. By the color heat on the board here. I think that was going to happen. By the color of the board here, that thing's been hot for a while. All this stuff was not really designed with longevity, especially Sencore equipment. It was not designed with longevity in its mind. It was sold to get it out the door. That's a transistor right there that's in question. Got a G marking on it, and it looks like D40 something other. I find my glasses again. Let's see what this dude is. Like D40V5. Now, what is that? I have no idea. Let's get the trusty dusty old transistor checker out. Such as it is. Use this thing in forever. It says a BJT NPN. Collector is 1, base is 2, and emitter is 3. So collector, base, emitter, so that's E, B, C. But check's good. Says so. So it says E, B, C. I don't know if you can read that or not. Find something to measure on here. I know what I saw as far as that junction and what went. Yeah, let's see. Definitely ain't checking like I'm used to them checking. We had a shorty transistor. I'm telling you, this thing don't check good to me. I'll put it back in this tester one more time. It's NPN. Collector. So that's emitter, base, collector. It says emitter, middle one is base, this one's collector. That's what it's saying. I agree with that, as far as that goes. But I don't trust it because, or I don't believe this transistor is good, in my opinion. But again, my opinion ain't worth a whole lot. So I'm going to check it with a little bit better NPN, which means I'm going to check it. I'm going to check, put a positive lead on the base, which is the center, according to this thing. And I'm going to check it, just like that. I have a forward reading now. Okay, I have a forward reading on that, which is good. I didn't have that a while ago. I've got a forward reading on that, which is good. Measure between, no shorts. I'm going to reverse polarity. Okay, so now we're going to measure it the opposite direction. Okay, I couldn't get a good measurement on my ohmmeter using just the standard old test leads. I had to go to my little small precision clip lead. Get a good bite on it. I'll attempt to get this thing back in here. Making a lot of noise. I'll cause that lead there ain't wanting to go in. Sorry about that, it's just taking forever to get this stinking transistor back in there. Alright. What I was getting at a while ago, at least I think it was, is these things were not designed perfectly. Got many issues with their designs. Just old school, they use big resistors to drop a lot of voltage. Well, we'll get back in, see what it does. Attempt to turn it upside down this time. It's got some voltage measurements here. So I'm going to go back to my digital voltmeter. Loosen that, turn it, here we go. And so you're just going to put it 200 volts, we'll ground this. May or may not work, I do not know. At the point, I don't really care. We didn't like that. Didn't like that at all, so what did I do? Possible put the stinking transistor in backwards. Probably, on me. Don't think so. I don't know, be right back. Alright, got a decision to make. When I replaced that transistor back in the circuit there, all of a sudden I had excessive current draw. Thought I had put the transistor in backwards. That I didn't think I did, but I went ahead and changed the transistor I had checked. I thought I might have put it in backwards, but I went ahead, pulled it out, turned it around, put it back in, tried it, of course, you know. Drew a little less current, but I still think I had it back in right to begin with. But still drawing a lot of excessive current. I took the two transistors out and they did check good. Both of them did, so that's about the only active components in there other than a few diodes. But this transistor here, which is the first one I pulled out, if you dick around with these any length of time at all, they'll break. And I dicked around with this one too many times, and the collector lead, I'm sorry, the base lead broke off of this thing. So where is, you know, I try, okay, so where's my short? Guess what? The rectifier diode that was getting super hot a while ago, which would be CR1, is shorted. I guess it couldn't take it. So we'll measure one more time out of circuit. Dead short. If I can get you over here and look at it on that meter. Zoom you in there. Try to at least turn all this stuff around. Well, I wouldn't give her a really good. I'll get this eventually. Loosen that collar where I can turn it around with ease. There we go. That is a shorted diode. I'm on the R times 1 scale. Either way I go, that diode is shorted. So, not only do I need a diode, I need a transistor. You know, I had to bend the lead straight on this transistor to put it in that little tester of mine. However, I just knew that base was facing the front, and it should have followed just like the other one did. The other one, the base was facing the front of the transistor. I don't think I put this thing in backwards. I just think that diode just finally died. Which that diode could have been bad to begin with. So I don't have this transistor in stock that I know of. I'm going to try to identify it. and see if I've got anything close to it. So at this point, there's no point in doing a video anymore. This is more like an experimental video. I doubt anybody even likes it. Probably just sound like the ramblings of some old coot, which is fine. But as I do these, I get better. I learn and I'm starting to think ahead now on how to do these videos. Used to, I just jump in and just start making them, but I got to really think this thing out in a storyboard fashion. You know, okay, what am I going to work on? Okay, what points are we going to discuss working? You know, talking about. You got to have a flow here, and personally, I'm just letting you come along for the ride. You know, you and I, if you want to go that way, you and I can sit down and get this piece of equipment. Hey, it ain't working. Okay, well, why ain't it working? What's the symptoms? So we get the symptoms, and okay, well, it's drawing off too much current. Okay, why is it drawing too much current? Well, it must be the power supply. So then we look at the power supply, and we find a problem there that we're drawing. One circuit is drawing a lot of current when it's not even connected to anything. It really shouldn't be drawing any current when it's connected to anything. So and when we started going down that little rabbit hole, you know, we find these two transistors here that, are they good or are they not? You know, they are in the circuit and they're the active component, so, you know, active components do fail. So we went down that rabbit hole, and unfortunately I got some collateral damage out of this. And we did verify it was that circuit, and once I pulled that diode loose, all my current went away that it was drawing from the AC supply. So that's where we're at. So I'm going to see A, if I can identify this, and B, find a source. I've got boxes of old transistors out in my work shed, but I ain't 100% sure I want to go dig through all this mess for a project for this device. So I haven't decided yet if I'm going to complete this or not. But now my curiosity's up. I want to find a schematic, if I can, of what that circuit's made of and what it should be doing, and also see if I can find this transistor. And I'm pretty sure that diode is nothing more than an N1N4007. I'm pretty sure that's all it is. So I might even figure out a way to jerry rig this, is what I'm probably going to wind up doing. If I can solder on that base tab, I'm going to solder a wire to it, put that dude back in, change that diode, see what happens. So anyway, I will talk to y'all later. Okay. Round 3. I just tacked a lead on the base of that transistor, put it in like I thought it was supposed to be, replace that shorted diode. Here we go. And we are not drawing hardly any current now. I'm impressed. Could I have lucked out? Alright, it's got some test points on here of plus 35, plus 15, and I think plus 30. So let's see if I can measure that. Let's try it again, make sure it didn't blow it up. Let's see if we can measure those test points, which is what I was hoping to do earlier. So let's see, 15 volts. Couldn't be, I'm not getting nothing because that wasn't touching nothing, I hope. Let's see. Alright, I got 17 on the 15 volt line. I got minus 46 on the 35 volt line, and I got 29 on the 30. Now that 35 volt line probably is high. Okay, I got all my voltages. I think. Of course, this plus 35 volt line right here is showing minus 46. Not sure why that is. Again, I may be measuring the wrong line. Yeah, I think it was. Okay, well, we'll plug it in and see what happens. Be right back. Alright. We're back again. Excuse me. Got the power supply board reinstalled in the device. Guess it's time to turn it on and see what happens. It's either going to go or it's going to blow. So far it ain't blown. I am drawing a whole sum total of 35 amps. Light is not glowing anymore. And I don't know what the pinout is on the top, but let's just see if we can get some of those expected voltages. So I'm just going to go here. There's 20 volt, minus 15, assume that's good, plus minus 51, 8.9, beats me, minus 15, 8.9, 8.9, I don't have no idea. Here's 20, minus 15, don't know what this is. That was 159 volts there. I don't know. Turn it off, turn it around, see if I got anything coming out of it. Phone needs a lot more work. Don't want to put a lot of time and effort into this whole thing. I mean, I don't even work on televisions. I haven't worked on a TV in 40 years. Yes, it's been that long. So let's turn it back on, see what happens. Put a voltmeter on power supply right here. I get a full 34 volts out of it. That's good. That's what I wanted. So far so good. See if I got any RF out. That found me a BNC cable. So let's see if I got any kind of signal out at all. Yeah, it's producing something. Find my silly scoop. Zoom it in there. Oop, wrong way. Alright. It's doing something. Very low signal. Could be indications of a bad filter. Looks like we might have a bad filter, but hey, it's doing something. Looks like we may have a bad filter. Well, doing something. Let's see, let's go to second IF output. No. Adjacent sound. I know what I want. Let's see. We'll set it for video pattern, I think. Let's see, meter output, VTR drive output, let's see. Audio 3.58 megahertz crystal oscillator, video pattern. I'll find something here. There we are. That's what I'm looking for. That's doing something. But it's back to how I had it before. So I am not going to worry about that. It looks like it needs a lot more work. My videos need a lot more work too. Anyway, thing is doing something. It's back to where I had it before it blew up. So I'm going to leave it alone since I don't have no schematics. The schematic online is going to cost me anywhere from $22 to $40. And since I don't use this stupid thing, I don't really care to spend any money on it. I've got it running, which is fine. Like it needs filter caps because that waveform looks got a little hum it looks like in it. But I'm not spending no more money on this. I fixed this for free, got the power supply working again, got the load off of it, so I don't think it'll blow any more fuses till it blows up again. One day in the extreme future, I may work on it again. So, by the looks of it, I think that diode was bad. I have not seen one do that in a long time. Even though I checked it in circuit, it checked okay. Apparently it was breaking down under load, and which that is, I have not seen that in years. But thought I'd put that transistor in backwards, but apparently not. But now that I've got the transistor, I tacked the lead back onto the base, because like I say, I broke the base lead. Tacked the lead back onto it, soldered it back on the board, put a new diode in, and wham, thing is working, drawing what it should be drawing. So, wasn't much of a video, but at least it's something I can put together, see if I can hone my editing skills a little bit. So the next one I'm hoping to, I don't know what it'll be yet, but I may get in a little bit more involved. But anyway, alright, well, thanks for having me with me. Don't hurt me too bad in your thumbs up, thumbs down. As I do these and edit them and look at them later on, I kind of get an idea what I need to do and what I don't need to do. But the basic philosophy of troubleshooting is, okay, what's it supposed to do and how does it do it? And we went to the power supply, says, okay, what's getting hot? This thing shouldn't be drawing this much current with all the outputs disconnected. And when we used the FLIR infrared detector, we found that diode getting extremely hot, and we started looking into that. That's when we found that there was something in that circuit. Don't know what circuit it was. We found something in that circuit was getting too hot, and once I like it goes back to that transistor and that diode. You know, we checked the transistor. I pulled that one transistor out because it wasn't checking properly in circuit. But then again, apparently my test probes wasn't making good connection. When I put the little mini jumper leads on it and got a good connection on it, then I was able to get a good junction. So when I put it back in there, that's when the thing started drawing excessive current, which made me think, oh, I got it in backwards. When it turns out I do now have it in backwards. Apparently that diode was the main problem to begin with, and it just happened to fail and stay failed. So that's the way I'm going to run with this. So anyway, I'm going to get it back together, which is all boring stuff. I'm going to put it back on the bench and make sure it works one more time, and I'm going to call it a day on that one. So anyway, I hope y'all enjoyed it, or at least got some mild amusement out of it, or maybe it put y'all to sleep, I don't know. But anyway, we'll talk to you next time. Alright, see you from Hunter Labs.